Hi guys, let's look at the remaining homework questions of exercise 15A. We're still on the chapter Similarity. Okay, the first homework question that we do in this video is question number 15. It says in quadrilateral ABCD, diagonals intersect at point E such that, okay, let's look at this as the quadrilateral. So this is A, B, C and D. The diagonals intersect at point E, okay, such that AE upon EC, which is what we are looking at, are these lines. Okay, AE and EC, okay, is equal to BE, which is here, and DE, which is here. So these are the two lines which are in ratio, and we need to prove that ABCD is a trapezium. So again, I think we've already identified the two triangles that we are looking at, AEB and DEC. If we can prove these two similar, then we should be able to get that the angles are equal, which means we should be able to prove that these lines are parallel. Okay, so in triangle ABE and triangle CED, what is available to us? Point number one, angle AEB is equal to angle CED. This is vertically opposite angles, so they need to be equal. What we know is AE, one second, AE upon CE is equal to BE upon DE. This is given. If I can use alternando with this, what I'll get is, using alternando, what I get is point number 3, which is AE upon BE is equal to CE upon DE, which means AE upon BE is equal to CE upon DE, which means the two sides which include the common angle, in this case the equal angle, are in the same proportion and the included angle is equal. So using side angle side test, what we get is point number 4, triangle AEB is similar to triangle CED using SAS test. What this gives us is, therefore, angle EAB is equal to angle ECD. This is corresponding angles of similar triangles are equal. Since these are alternate angles, therefore AB is parallel to CD. Therefore, quadrilateral ABCD is a trapezium. We've been able to prove that one pair of opposite sides is parallel. That should give us the fact that this is a trapezium. Good, let's look at the next homework question. The next homework question we have is question number 22. It says in triangle ABC, AD is perpendicular to BC. Okay, let's just draw the rough diagram. So this is A, B and C. AD is perpendicular to BC, something like this. Next, and AD square is equal to BD into CD. We need to show that angle BAC is equal to 90 degree. Okay, what is given is AD. Okay, so point number 1, AD square is equal to BD. AD square is equal to BD into CD. If I write this in the ratio form, or rather fraction, AD upon BD is equal to CD upon AD. If I highlight this, let's see how it looks like. It means AD, which is here, upon BD, which is here, is equal to CD, which is here, upon AD, which means again a pair of sides are in proportion and the included angle in both the cases, angle D, is equal, which means I should be able to prove that these two triangles are similar. Let's see if this will help us in any way. Okay. So in triangle ADB and triangle ADC. Point number 3, which is angle ADB is equal to angle ADC is equal to 90 degree. This is given. Point number 4, of both these is given. Point number 4, we have AD upon BD is equal to CD upon AD. This is given from point number 2. Therefore, by side angle side test, what we get is triangle ADC is similar to triangle. Okay, I have written A later. Okay, ADC later, but doesn't matter. I've written ADC first. So angle A would be equal to angle B. Yes, so angle A is equal to angle B, that's here. D is equal to D and C is equal to A. So that's ADC is similar to triangle BDA. What this gives us is, therefore, angle DAC is equal to angle DBA. Let's say is equal to X degree. DAC is equal to X and DBA is equal to X. Perfect. And angle DCA is equal to angle DAB, let's say is equal to Y degree. DCA, which is here, is equal to angle DAB, which is here, is equal to Y degree. Reason for this, corresponding angles of similar triangles are equal. So what we get is point number 7. Therefore, in triangle, let's say ABD, what we have is 90 degree plus X degree plus Y degree is equal to 180 degree. This is angle sum property. What we get is, therefore, X plus Y degree is equal to 90 degree. Now point number 8, therefore angle BAC, which is equal to X degree plus Y degree, is equal to 90 degree. Hence, this is what they wanted us to prove, that angle BAC is 90 degree. Good, let's look at the next homework question, which is question number 25. Question number 25 says, through the midpoint M of CD of parallelogram ABCD, line BM is drawn intersecting diagonal AC in L and AD produced somewhere. Okay, let's just draw a rough diagram first. So that's our parallelogram. Okay, through the midpoint M of CD, BM is drawn intersecting AC at L. So this is AC. It will intersect at L and AD produced at E. Okay, something like this. Perfect. I think I've got my diagram. This is A, B, C, D. This is M, the midpoint. This is L, and this is point E. Let's read the question again. Through the midpoint of CD of parallelogram ABCD, which means DM and MC are equal. Line BM is drawn intersecting diagonal AC at L, which is here, and AD produced at E. Perfect. We've got our diagram correct. Now see, what do we need to prove? We need to prove that EL is equal to 2 times BL. So first let's try and figure out which two triangles we should try and prove similar, and that should make our life simple. So I can see one triangle here and one triangle here. Both of these are vertically opposite triangles. So I have angle L equal. So I should be able to prove these two triangles similar, right? And I also know MC is half of AB. So I should get the ratio of MC upon AB is equal to 1 upon 2. Let's just start with this question then. So in triangle MCL and triangle ABL, point number one, angle MLC is equal to angle BLA. Reason, vertically opposite angles. Point number two, angle MCL is equal to angle BAL. Reason, alternate angles since CD is parallel to AB. Yes, that's correct. These two angles will be equal, which is this angle here and this angle here are equal. These are alternate angles. What this gives us is point number three. Therefore, triangle MLC is similar to triangle BLA by AA test. What does this give us? This tells us point number 4, ML upon BL is equal to MC upon BA is equal to LC upon LA. This is CSSD. Point number 5, therefore ML upon BL is equal to MC upon AB is equal to LC upon LA is equal to 1 upon 2 since MC is equal to half of AB. This is given, right? MC is half of CD, which means it's also equal to half of AB. Okay, now we've got one thing correct. Let's see how can we prove something else here, because we will need the ratio of EL upon BL. So EL and BL, what triangle do they form a part of, which I can try and prove similar? I think I can look at the triangle here, which is ALE, and I can look at the other triangle BLC. Yes, it should help me. ALE and BLC. I should be able to get the ratio of EL upon BL. Okay, so in triangle ALE and triangle BLC, what can I get equal? I have angle ELA is equal to angle BLC, which is basically this angle that I'm referring to, which I have marked with a dot. This is vertically opposite angles are equal. Point number 7, again this angle here and this angle here should be equal since AD is parallel to BC and AC is acting like a transversal. So angle EAL is equal to angle BCL. This is alternate angles. What we get is therefore triangle ELA is similar to triangle BLC using AA test. What this gives us is point number 9, EL upon BL is equal to EA upon BC is equal to LA upon LC. This is CSSD. We have LC upon LA here and we have LA upon LC here and we have EL upon BL. Okay, so from 5 and 9 we get point number 10, which is LA upon LC, which is equal to LA upon LC, which is equal to EL upon BL, which should be equal to 2 upon 1, because here LA is in the top, here LA is in the denominator. So we are taking the reciprocal basically. So this is 2 upon 1. What this gives us is point number 11, EL is equal to 2 times BL. That's what we had to prove, hence. So interesting question. We had to use similarity 2 times for 2 different triangles given in this figure. Good, that brings me to the last homework question which we had for this exercise, which is question number 27. Finally, some diagram given. Let's look at this question. In right angle triangle QPR, PM is an altitude, QR is equal to 8 centimeter, MQ is equal to 3.5 centimeter. We need to find the length of PR. So if this is 8, this is 3.5, then this is 4.5 centimeter. Let's just write that down. MR is equal to 8 minus 3.5 is equal to 4.5 centimeter. We need to find the length of PR here. So which two triangles should we try and prove similar? Let's look at the big triangle PQR and let's look at PMR. Now we can look at these two triangles. So in triangle PQR and triangle PMR, let's draw a rough diagram. This is the rough diagram that I'm drawing. This is point M, this is R, this is P, and this is P, this is Q, this is R. So angle P here is 90 degree, angle M here is 90 degree, and I can notice that angle R and angle R are common. So we've got our answer. AA test, these two triangles should be similar. So angle RPQ is equal to angle RMP is equal to 90 degree. This is given. Next point, angle PRQ is equal to angle MRP, common angle. What this gives us is, therefore, triangle PRQ is similar to triangle MRP using AA test. So let's figure out the CSSP for this. This is PR upon MR is equal to PQ upon MP is equal to RQ upon RP. This is CSST. We need to figure out the length of PR, which is I will be using this. Is MR given? Yes, we've calculated MR, which means PQ. So I will be using these two, right? PR and RP. And I have RQ also given. Yes, RQ is also given. So PR into PR should be equal to MR into RQ, which means MR is 4.5, RQ is 8. Therefore, PR square is equal to 4 into 8, 32, plus 4, that's 36 centimeter square. Therefore, PR is equal to 6 centimeter. Perfect, we've got our answer. Good, that brings me to an end of this homework video. Take care, be safe. If you have any questions or queries, feel free to write into me. Bye bye.